Alright, 4.4, the other trig functions, part 1. We're just going to focus on tangent and cotangent with this one. First graph we're going to have is 4 cotangent x equals y. With this one, here's the main change. As you are aware, the asymptotes are going to stay the same. Okay, right? 0, pi, 2 pi, and so on and so forth. So, with this, as before, I'm going to do this in black. This is for just the original y equals cotangent x. It would be something like this. Ooh, that was rough. Let's try it again. Okay, and then halfway here was 1, right? And halfway between there, which was 3 pi over 4, was -1. Now with 4 cotangent x, what's going to happen is it's going to shoot up a little quicker, right? So at these values that were supposed to be 1, you're going to get 4. And at this one, you're going to get -4. So let me plot them. We're going to go for blue. So up here, we'll call that 4. We'll call this -4. Still going to go through that 0 right there. And we're good. And the same thing here. It's going to shoot up a little quicker. It'd be a little nicer. And there we go. There's your cotangent graph. So the main difference is, it's so hard to draw on this thing. The main difference is it's going up quicker and decreasing faster, as opposed to the normal graph. Okay? Now we got y equals 1/2 tan of 3x. So remember tan, we have asymptotes at pi over 2 and -pi over 2 originally. Okay? Now that let's spread them out a little bit, just so it's easier to visualize. Okay, that's x equal to -pi over 2 and x equal to pi over 2. And what's a normal original graph, which we'll do in black again, would be that, right? In this case, since it's 1/2, it's not going to be increasing as fast, right? It's going to loll down here a little bit more, and not to mention that 3. What does that 3 do? 3 changes the period and all your asymptotes. So if whatever value this is, divide all your asymptotes by 3. Okay? So now your new asymptotes are going to be at -pi over 6 and pi over 6. And it's going to kind of loll a little bit more than what it normally would. Increase up there. So that value will be, I'll label it for you. That's going to be pi over 12, comma 1/2. How do I know that? It's halfway in between the middle, which is 0, 0, and the asymptote, which is pi over 6. And for the other one, -pi over 12, comma -1/2. Now we got this scary tangent function, but similar to what we did with cosine and sine, make that 2x minus pi over 4. And remember, one cycle is from 0 to pi, okay? So from 0 to pi, we need to isolate x. Two x there, and then 5 pi over 4 here. Divide by 2, we're going to get pi over 8. It's less than or equal to x. It's less than or equal to 5 pi over 8. So that's one cycle there. And with a cycle of tangent, just keep in mind, there's going to be an asymptote right in the middle of whatever our cycle is. So right in the middle of pi over 8 and 5 pi over 8 will be 3 pi over 8. here's the estimate of 3 pi over 8. And then what's happening here? We're shifting up 1, right? So that point pi over 8 would, instead of it being at 0, will be at 1. So it's pi over 8, comma 1. And then just like it would, it's going to shoot up towards the asymptote, come from left to right, and then left. Let's keep in mind that's 5 pi over 8. That will also be at 1, right? So that's and then here, what's happening? It's decreasing down there. Okay. To pick another value, just for accuracy, if this is 2 here, right? Let's say we pick the halfway point between 3 pi over 8 and 5 pi over 8, which is pi over 2. We put pi over 2, and what's happening? Pi over 2 will get us pi minus pi over 4, which is 3 pi over 4. And tangent of 3 pi over 4 is root 2 over 2 plus 1. So it would be 2 plus root 2 over 2, which is a little over what? That would be a little, rather negative, right? It's a negative root 2 over 2 because it's 3 pi over 4. So that will get us 2 minus root 2 over 2, which is, what, about 0 point something. So right there, halfway, would be about there, and it's going to keep decreasing. And just for note's sake, period is for cotangent tan is pi over b. Whatever the b value is divided by pi, that's your period. I'm going to just skip around here to horizontal shift. Horizontal shift refers to c divided by b and its opposite. Okay. Now, if you have a problem where it's asking for the horizontal translation and the b is factored out, or you need to factor it out, do that, and then it's whatever your h is. And k is what goes up and down. To reiterate, if there's no b, you can just simply say horizontal translation. And you can simply just say that's h, so that's your horizontal translation. As far as horizontal shift, it's still can apply, right? So if you don't have it factored out, then you can just simply go C over B. So depending on what you're given, roll with it. Okay. Appreciate watching. We'll see you later.